Hello, my name is Hasida. I am part of the AI Course Assistant team. This is my solo architecture review of the AI integration component I built. What is the prototype? The AI Course Assistant is a web-based chatbot that helps students learn by answering course-related questions. The system has four main components built by four team members. My role: AI integration. I built the AI integration layer. This component connects to the Groq LLaMA, manages the LLaMA language model, scores response quality, and tracks token usage and costs. The architecture of my work. When a student asks a question, this is what happens in my component. First, the backend calls my callGroqAPI function with the student's question and course context. Second, I build a system prompt. This prompt controls what the AI can answer. For example, for a classification module, the prompt says, only answer questions about classification. Do not answer off-topic questions. Third, I call the Groq API with specific parameters. Model is LLaMA, 3.18 billion parameter instant. Max tokens is 1024. Temperature is 0.7. Fourth, I receive the response from Groq and score it on 5 dimensions: clarity, completeness, accuracy, engagement, pedagogy. Fifth, I track tokens in a token stats object because we pay per token used. Sixth, I return the response with the quality score to the backend. Why I designed it this way: token tracking. We need to know how much the AI service costs. By tracking every token used, we can see patterns and optimize costs. Quality scoring on 5 dimensions. Not all AI responses are equally good for education. By scoring on multiple dimensions with different weights, we ensure students get trustworthy answers. Accuracy is weighted highest at 25% because wrong information damages education. System prompts. The AI model can answer anything. By providing a system prompt, I control what it answers. For example, the classification module prompt explicitly tells the AI to refuse off-topic questions. Max tokens limit. Without a limit, the AI could generate very long responses, wasting tokens and costing more money. 1024 is a reasonable limit for educational responses. Temperature at 0.7. Temperature controls randomness. Lower temperatures like 0.3 are too predictable and boring. Higher temperatures like 0.9 are too creative and unreliable. 0.7 provides balance, which is good for education. Error handling. Network requests fail sometimes. I catch 7 types of errors. Timeout. Network errors, authentication failures, rate limits, server errors, validation errors, configuration errors. For each error type, I return a friendly message instead of crashing the system. How it connects to the team. Sujeewa's backend calls my callGroqAPI function. He depends on my function, returning reliable responses with quality scores. Nadeesha's frontend displays the quality score that I calculate. Students see the score and decide if they can trust the answer. Nipuni's monitoring tracks the tokens that my function reports. She monitors costs to ensure we stay within budget. My code behavior, token tracking. Every request updates the token stats object with total tokens, prompt tokens, completion tokens, and quality score. This allows us to calculate averages and see trends. Quality scoring. The function analyzes the AI response and assigns scores for each dimension. These scores are weighted and combined into a single overall score from 0 to 100. A score above 80 means the response is trustworthy. System prompts. Different modules have different prompts. The supervised learning module, regression module, and classification module all have specific instructions. These prompts are consistent and control AI behavior effectively. Error handling. When a timeout occurs, the system catches it and returns a message asking the student to try again. When the API key is invalid, the system catches it and alerts about configuration errors. This keeps the system stable. How and why this matters for learning. The architecture ensures that students get reliable, trustworthy educational content. The quality scoring tells them which responses to trust. The cost tracking ensures the project remains feasible. The error handling ensures the system keeps working when problems occur. Proof I understand what I built. I can explain why each design decision was made. Token tracking solves the cost problem. Quality scoring solves the reliability problem. System prompts solve the focus problem. Error handling solves the stability problem. I made these decisions. I implemented this architecture. I understand how each component works and why it exists. That is the architecture of the AI integration component I built. Thank you.